Okay, so we're going to be discussing the behavior near the asymptotes of f of x equals 3x minus 2 over x plus 3, and hence deduce their equations. So the behavior near the asymptotes is essentially like on either side of the asymptote, what is it like? What is the function at? So the way we can deduce the asymptote is, well, if the denominator is 0, we have a vertical asymptote as that function is undefined. So if we make x plus 3 equal 0, we get the first asymptote, which is x is equal to negative 3. Now we have to focus on finding the behavior on either side. The behavior is essentially, well, if we have the function over here, and we pick a point like over here and over here, where is the function going to end up? And so the way we can do this is picking two numbers that are very, very close on either side of x is equal to negative 3. So we can pick, for example, negative 2.99 and negative 3.01. Those are just very obvious ones on either side of negative 3 that can give us an idea. And when we're discussing behavior, we're not looking for a specific value, because when we have the function x equals negative 3, that makes it undefined. We're looking for, is it getting increasingly bigger or increasingly smaller? So let's take the x is equal to negative 2.9 and substitute that in. So if we put this into our calculator, let's just do that to make it more efficient instead of doing it manually. So we go 3 times negative 2.99 minus 2 divided by negative 2.99 plus 3. And that gives us negative 1,097. And this value itself is not important. What's important is that it's a negative value and it's very large. So that suggests that if you get infinitesimally closer to x equal negative 3, we're going to keep getting a bigger and bigger negative value until it reaches negative infinity. Oops, that was an H. Negative infinity. So essentially what we can say is as x tends from the positive side of negative 3 plus, because it's going from it's negative 2.99 is more positive than negative 3, we get f of x to be tending towards negative infinity. And if we take it the other way around, if we do it with x is tending towards negative 3 minus, in that we have negative 3.01 as that minus value. If you substitute that in, we should get a function that's tending more to the positive value. But let's just double check that. If we put that in, so 3 times negative 3.01 minus 2 divided by negative 3.01 plus 3. And that gives us, so when x is equal to negative 3.01, we get 1103, which is the opposite, it's positive 1103. So it's pretty much, no matter how much closer you get to negative 3, you're going to be approaching it from the positive side. So f of x would tend towards infinity, as we have a very large value over here that will keep getting larger as we get closer to negative 3 from the positive side. Another way to think about this is that if you substitute each of these values into the numerator and denominator manually, so if you substitute negative 3.01, for example, into the numerator, you get, so negative 3.01 is similar to negative 3, which will give you negative 9 minus 2, which gives you negative 11 in the numerator. In the denominator, you cannot substitute negative 3, as that will give you 0, so we have to substitute the real value, which is negative 3.01, which will give you negative 3.01 plus 3, which gives you about negative 0.01. So as you can see, we have a very big positive negative number divided by a very small negative number. And that's going to give you a very big positive number, because negative over negative cancels out. That's just another way of thinking about it. You can think of it in the same way with negative 2.9 and negative 3.01. Now, we still have horizontal asymptotes that we haven't yet identified. And the way we can do that is by dividing the numerator and the denominator. So if we do 3x minus 2 divided by x plus 3, so what do we need to put into 3x minus 2? How many times do we need to put x plus 3 into 3x minus 2? Well, we have to base it off the coefficient of the largest power of x. So this can fit in 3 times. And when we do that, we get 3 times x plus 3, which becomes a remainder of negative 11. So the remainder is negative 11, but that doesn't matter. What we know is that the asymptote is going to be 3. So y is equal to 3 is our next asymptote. So again, we have to do the same things, look at the behavior on either side. So we can pick 3.01 and 2.99. So when we put 3.01 into the function, as the y value, by the way, so f of x is 3.01, so 3.01 is equal to 3x minus 2 over x plus 3. So I'm just going to erase this for now and I'll bring it back later. So 3.01x plus 9.03 is equal to 3x minus 2. Collect the x's. We get 0.01x is equal to negative 11.03. So x is equal to, and then we do the division. And we get a very large number, around negative 1103, so negative 1103. And again, this demonstrates that x is approaching negative infinity because the negative value over here is very large. So the way we write this one is as x approaches negative infinity, we get f of x is approaching 3, but from the positive side because 3.01 is greater than 3. And if we were to do this now for our other y value, which is 2.99, so y is equal to 2.99. So we have to solve for x. So that gives us 2.99x plus, and then 3 times 2.99 is 8.97. The specific values aren't what matter. What matters is the direction that the function is going in. And then if we rearrange, we get 0.01x is equal to 10.97. So x is equal to 10.97 divided by 0.01, which is 1,097. But again, that the number itself is not the point. The point is x is tending towards infinity because it's getting much larger. So as we get closer and closer to 3 from that direction, it'll go closer to infinity. So the way we write this one is as x tends towards infinity, f of x tends towards 3 from the negative side.